Hi, we're going to take a look at a review of all radicals, everything with an index of 2. And I say index of 2 because here in this little valley, that little V, you don't always need to have a number down there, but when there is no number, there's this magic hidden 2 that just says I need a number times itself to give me what's inside. A lot of times we look for perfect squares, numbers like 4, 9, 16, 25, 36, and so on. If we don't have them, we have to break these numbers up into those numbers. So let's try and find them. So 27, I need two numbers multiplied together to give me 27. Those two numbers end up being 9 and 3. So since 27 is under the house, 9 and 3 are both under the house, it's the same thing. We're just taking that and we're just kind of making it spread out into different ways. Um, when I get a perfect square, I can then take it outside that square root house. So this square root of 9 then turns to a 3 outside, because what times itself gives me 9? 3 times 3. This 3 is still under that square root symbol, so it stays under that square root symbol, and we leave it. Next to it, we have 32. So 32 is not a perfect square, but we can break it up into two numbers where one of them is. Those two numbers, we could say 16 times 2. The square root of 16 is going to give us 4. Square root of 2, we can't do, so we leave it, and it stays inside. What about when we have variables now? So something like this, I want to look at this as if I have 4 separate problems. And I'm going to break them up into each one. So I'm going to look at the number, I'm going to look at X, look at Y, look at Z, all separately. So 144, I know, is going to give me 12 outside. Okay. X to the 6th power is a perfect square. I'm looking for something times itself. Now, what two things multiply together to give me that? Well, just remember, when we're dealing with exponents, we need to add the exponents together. So 3 plus 3 gives us 6. What gives us, what gets repeated? The x to the 3rd. So that comes downstairs, out of the house. Y to the 7th. Now here's a weird one. So when you have an even exponent, all you gotta do is cut it in half. But when you have an odd exponent, I need to split it up like I split these numbers up. Now what I'm going to break it up into is y to the 6th and y to the 1st, because when I add those exponents with that same base, 6 plus 1 gives me that 7. Now, these are both under square roots. What's the square root of y to the 6th? Well, it's going to be kind of like what we did with the x. It'll be y to the 3rd. And since those are under the square roots, those are under the square roots, y to the 1st is still underneath that square root symbol. We're going to leave it under that square root symbol. I'm going to put it off to the side a little. Now, z to the 101st power. Why get something with such a large exponent? Well, we're still going to do the same thing like we just did with a y. So I want to break that z up and say z to the 100, z to the 1st. When I add my exponents, I still get 101. That's an even exponent, so all I'm going to do is cut it in half, z to the 50th power, and that z to the 1st, it stays inside that house. And do I really need those exponents there? No, not really, so you could get rid of them if you like, but there's your big answer. What if we have two of these type of problems that are being multiplied together? Well, we need to put them together first, and then we're going to break them apart again. So let's put together like pieces and stuff. So my outside numbers, I have 4 and 4 giving me a 16. So let's multiply them. Inside, now everything else is left inside. 2 times 6 gives me 12. X times x to the 3rd. Remember, there's an exponent of 1, so we have x to the 4th. And I have only that one y. Okay, now we want to simplify just the radical. Okay, so square root of 12. I can break that up into two numbers. I can say 4 times 3. The square root of 4 comes outside as a 2, so I'm going to have 16 times a 2. That 3 stays inside. X to the 4th, that's a perfect square. It's an even exponent, just like what we did over here with the 6 and the 100. Let's just cut it in half. We're going to say x squared. And the only thing that's left is the y, and it's all alone in there. I can't do that, so we leave it inside. And now one last step of putting things together. 16 and 2 gives me 32x squared, square root 3y, and there's that ugly answer. Okay, what about addition and subtraction? Well, here I have three terms being added and subtracted together. I can't combine them. They're all unlike terms. I can only combine stuff that has like radicals when we add and subtract. So I need to break each one of these radicals. I got to break them down. So let's simplify. Square root of 12, well, we just know splits up into 4 and 3. 4 times 3, square root of 4 gives me a 2. And then I still have that 5 outside, giving me 10 radical 3. 27, we broke it up over there. So we have 9 and 3 giving us 3 radical 3 with a 2 out front. So that's a 6 radical 3. And then 32 we broke up over here. So we know that's going to be 16 and 2, which gives us 4 radical 2. So minus 4 radical 2. Now, we broke everything down as much as we can. Now we can combine with whatever we want to combine, like radicals now. So 10 plus 6, 16. We're talking about radical 3's. And this radical 2, there's no other radical 2's in this group, so we just bring it down for the ride. And probably the most complicated, or maybe the most work-intensive one, is multiplication. So with multiplication, we need to remember that we need to distribute. So I'm going to take this 6 radical 3 here, and I'm going to distribute to everything in the second parenthesis first. So let's do that. 6 radical 3 and radical 3, I get 6 radical 9. 6 radical 3 and negative 2 gives us only these outside numbers, so negative 12 radical 3. Now I want to distribute my second term here, so 5 radical 2 times the radical 3. With multiplication, I'm allowed to multiply different radicals together. It's just adding and subtracting where they have to be the same. So I get 5 radical 6, and then I distribute here, and I get negative 10 radical 2. And now I'm back to, I want to see if I can combine, I want to see if I can simplify. And I can simplify. Square root of 9 is 3, so I'm left with 6 times 3, which gives us 18. And can I break 3 up? No. Can I break 6 up? No. Can I break 2 up? No. Are any of these like terms? They are not. So let's just bring all 3 of them down. So it may be ugly looking, but there's nothing we can do here. And there is a review of everything with radicals: simplifying, multiplying, adding, subtracting, and distributing.